coldest thing or place that comes to mind? Okay, so maybe you're thinking of Antarctica. Maybe you're thinking of a freezer or snow. Maybe you're thinking of a lot of really cold things. Well, up here at the Museum of Discovery, I have something that's colder than anything here on Earth. That's right, colder than the coldest point of Antarctica or the North Pole. Now, it's in this container, and it's so cold that I need some safety gear on, though. So that being said, I've got some safety glasses. These are going to help protect my eyes, of course, from any splashes or anything. But I also have some safety gloves. So I'm going to go ahead and put those on to protect my little phalanges over here. But what I have inside here is something called liquid nitrogen. Now, liquid nitrogen, you might have heard of nitrogen before. It is actually all in the air around us. It makes about 80% of our air around us. But we're going to take this lid off and we're going to see what that liquid nitrogen looks like. It's going to be, of course, a different form from the air around us. So let's observe. Now, immediately, we actually see some fog coming off, of course, our little cap right there. That's not the liquid nitrogen. Liquid's going to look a little bit more like water. Water's an example of a liquid. But let's check it out when we actually put it into this beaker. Wow. Okay, so this is our liquid nitrogen. It's this liquid, this clear, colorless liquid. And as you can tell, it is boiling. It is jumping all over the place right now. And you probably didn't necessarily think that cold things can boil. But yes, this is extremely cold and it's at its boiling point. And the temperature of that liquid nitrogen is negative 321 degrees Fahrenheit. Mind blown. That is so cold. So cold that if I didn't have a glove on and I stuck my hand right in there, it could give me frostbite within seconds. So I'm not going to do that. Now I'm going to keep that glove on or use some tongs to retrieve anything out of there. But I was thinking that we could actually cook with our liquid nitrogen today. And I'm going to cook with this first. So you're probably thinking, yes, this is a super stretchy rubber band. And we're going to see what happens when we put this stretchy rubber band inside of our liquid nitrogen. There was a little bit of a sound in there. Of course, it kind of fizzled a little bit. It sounded like it was boiling. But we're going to take it out. We're going to see what happens when I pick it up and put a little bit of pressure on it. So keep your eyes peeled. If you don't, you might miss it. It's going to happen very quick. Okay, so here we go. Let's see what happens. And wow, I don't know if you could tell. We actually just shattered that rubber band. That is insane. Okay, I'm going to explain it this time what's happening. Okay, we have this super stretchy rubber band. Now, it's an example of something we like to call a polymer, which are these chains, these links of molecules which make up everything in our world. And we're going to put it in there. And of course, it's super bendy, it's super stretchy, that rubber band. But once it goes inside that liquid nitrogen, it doesn't want to bend at all. It doesn't want to stretch. It's so cold that it just wants to stay in place. And of course, when we take it out, it stays cold for just a little bit. And we're actually able to break it, which is crazy. Now, I'm going to take this little piece right here, and almost immediately, I can warm it up pretty quick. And it goes right back to being stretchy again. That is the power of our liquid nitrogen, which is so cool. Okay, I want to go on to the next thing. Over here, I have a balloon. And who likes balloon animals? Raise your hand in your classroom. I hope everybody's raising their hand because everybody loves balloon animals. But here's the deal. I want to see if I can make a balloon animal with this one. Maybe we can make it work, okay? So here's what I'm going to do. I'm going to kind of put it below here. I'm going to let it be a surprise. So let's see what happens when I try to form something together. Let's see. Yeah, it's looking good. It's looking great. It's a snake. It's a snake. Thank you. Thank you so much. I appreciate it. I hope there was a chuckle or two. That's okay if not. But this is a snake. That's as good of a balloon animal as it's going to get. But we're going to put this snake, we'll call him Josh. So Josh the snake is going to go inside of our liquid nitrogen. And we're going to see what happens to it. Now, before we do, we need to talk about states of matter. So, you might not have learned about this quite yet, or maybe you're going to very soon. But there are three main states of matter. One is going to be something called a solid. Now, a solid is usually something that's going to be hard, kind of like this table or this floor. Now, there's going to be another one called a liquid. And a liquid nitrogen is an example. Of course, water, or maybe you love some Dr. Pepper or root beer. Those are all examples of liquid. Now, the other one's going to be called a gas. Now, a gas is going to be the air around us, as an example. So, something you might not necessarily see with your own eyes. But those states of matter make up almost everything. There's a few more, but I will say inside this balloon, we have a gas because we have the air inside there. So we're going to see what happens to this gas once we put it inside that liquid nitrogen. So here we go. Josh is going in. Let's see what happens. Here we go. Come on, Josh. You got this. Wow. Okay. Okay. So, oh, something's happening. I don't know. Okay. What is happening to Josh right now? This is crazy. Okay. We are actually completely fitting our balloon inside of that liquid nitrogen. It's actually crinkling up like a little piece of paper. That is crazy. Now, let me actually show you another one in another form. Oh, as you can see that close up right there. It's all crinkled up. But you're probably thinking, did it pop? Did something happen to that balloon to make it kind of shrivel up like that? Well, I'm going to explain using this one. It's a little bit bigger. So let's see what happens to its bigger brother, as you can see right here. Okay. So we've got our balloon actually making contact with that liquid nitrogen. Now, as soon as it does, you can actually see it kind of getting smaller and smaller. All that air is kind of going away. Now, believe it or not, there's no hole. There's no puncture because, of course, that's one way that you might see a balloon deflate. But what is actually happening? It's getting so cold, it's changing to another state of matter. So we talked about that solid, liquid, and gas. Now, of course, we had that gas inside there, but one state of matter that's going to take up less room, or the next one is going to be a liquid. We actually have a liquid inside of that balloon. Now, the reason why is because all of those molecules we were talking about that make up everything actually move in different ways depending on what state of matter it's in. So, in a gas, all of those molecules were all over the place, kind of bouncing around. But as soon as it got cold inside of our liquid nitrogen, they came really, really close together because they were so cold. They want to try to find other molecules to get close to. And so, for that reason, it actually changed from a gas to a liquid and took up a lot less room. But let's see what happens when we take them out. So think about it, form a hypothesis of what you think is going to happen as soon as we take it out. And let's see. Okay, so here we go. We got our big one first. I'm going to take them both out. Here we go. We got our big one. We got our smaller one. I'm just going to put them right next to. Whoa! Oh no! Okay, as we can see, it was starting to get big again. This one, I think this one did pop actually, but look at this one. Okay, our buddy Josh. Come on, Josh, you got this. Yes. Looky here. Josh is going right back into snake form. That is crazy. It was all crinkled up, and then it actually blew right back up again. That's because it was a liquid. All those molecules, as soon as it got warm, expanded and changed right back into a gas. How cool is science? That is awesome. Okay, I'm going to stick Josh over here to the side, and I want to move right along. Now, one thing you might not have done in a while is jump in a ball pit. I love jumping in ball pits, and I do have a ball pit ball right here. But we're going to use it, of course, for an experiment. So we're going to see what happens when we put this ball pit ball inside of this liquid nitrogen. Now, it's going to get nice and cold, and of course, it's made of this plastic. We're going to see what happens when we take it out of that plastic. And I'm going to put it in my hand, and we're going to see what happens when I put a little bit of pressure on it. So once again, form a hypothesis, form an idea of what you think is going to possibly happen to this ball pit ball. And we're going to find out. Ooh, Thomas is coming up. He's going to get a nice close shot of it in my hand. So it's getting nice and cold right now. As you can see, it's like we're sauteing. It's like I'm cooking right now with this ball pit ball right here. Okay, I think we're good. Okay, so let's see what happens. Here we go. You can see it's kind of steaming. Now let's see what happens in 3, 2. Wow! Oh, wow. Okay, I will say that was a dud. I'm not going to lie. That's not what's supposed to happen. But tell you what, we're going to put it in there. We might not gotten it cold enough, and I see it's going to actually have an issue. There's a little bit of a little piece missing there. So you know what? We don't need that one. I have a backup ball pit ball. Don't you worry. So once again, the green one's better anyway. So no worry. We don't need that yellow one. We're going to try this again, and we're going to put it in that nice cold liquid nitrogen. Now this time, if it doesn't work out again, I need everybody in the classroom to go, wah, wah, wah. Because, sometimes science doesn't always work out of how you expect it to go. But that's why we form a hypothesis, an idea in our mind of what's going to happen. And even if we're wrong, we can actually learn from it. All right, but I think we're nice and close and ready. That plastic's getting nice and cold. So let's try this experiment again. Okay, here we go. In 3, 2, 1. Wow, that is what I was expecting to happen. Now you can see that ball pit ball just shattered into so many pieces. I couldn't even possibly begin to count how many pieces it actually shattered into. Now, the reason why this was happening was very similar to the balloon. Inside that balloon, we could actually see it shrink and shrivel up and change to a liquid. And it was doing the same thing in there, except it was keeping that rigid outer surface with, of course, a kind of a thicker plastic ball, other than that latex balloon. But for that reason, that ball got really, really weak. So weak, in fact, that it didn't take much at all just to put a little bit of pressure on it for it to shatter into all these pieces. How cool is that? Okay, I'm going to put this to the side because it is snack time. That's right. I'm feeling a little hungry. So I have some Cheetos right here. Anybody like Cheetos? Feel free to raise your hand. No, awesome. Yes. Thomas loves Cheetos. I prefer the crunchy Cheetos. But you know what? Today, we got puffs. I'll go with it. That's fine. Don't you worry. But we're going to actually do something with this Cheeto today. I'm not just going to eat it regularly. I'm actually going to put it inside of this liquid nitrogen. I, get a brain freeze at ice cream, so I feel like this is not a good idea to eat a negative 321 degree Fahrenheit liquid nitrogen Cheeto. But you know what? We're going to go with it. We're going to see what happens. Okay. So as you can see, it's in there. It's getting nice and cold. And I'm a little nervous. I'm not going to lie. Okay, so we're going to get it, like I said, nice and cold. And, ice cream is even barely below freezing, which is 32 degrees Fahrenheit. So, again, this is going to be extremely, extremely cold putting this in my mouth. So we're going to see and observe what happens. I'm going to put down my mask for just a second so I can eat this. And let's see what happens. So promise not to laugh at me, okay? So hopefully don't, because I'm just so nervous right now. Let's see what happens. Woo! Okay, first of all, that was freezing cold. But second of all, you might have noticed something happening. I actually had fog coming out of my mouth in my nose while I was eating that. It kind of did look silly. So if you did laugh, don't you worry. It was really funny. But the reason why that happens, and actually it might have even happened to you this morning. This morning has been very, very cold so far. So if you went outside and you went, did you see your breath? I'm sure a lot of you are probably thumbs up, nodding your heads, because like I said, it's very cold. Now, the reason why that happens is because our mouths are really warm. Our body temperature on average is about 98.6 degrees Fahrenheit. And that outside temperature, at least this morning, was like 29 degrees Fahrenheit. And so that temperature difference actually created fog, this water vapor. So big temperature differences can actually create that fog, that water vapor. But this was a massive temperature difference when I put in that negative 321 degree Fahrenheit Cheeto. And so we can actually see a lot more fog in a really cool way. Okay, now moving right along, we do need to say goodbye to our liquid nitrogen. So say, goodbye, liquid nitrogen, you were fun. Or cool, I should say. All right. Okay. I'm going to put that to the side, but don't you worry. I have a lot more cool things to show you guys as well. Now, I want to ask you guys, who has taken a bath before? Okay, hopefully we have some hands up as well. If you have taken a bath, then you might know what the water does when you drain it. So with your finger, show me what the water does when you drain it. Okay, so maybe, if you're thinking about it, maybe it's going to do something like this, right? Almost looks like a whirlpool. Or some of you might recognize it as a tornado, right? It kind of looks like that weather phenomenon that we know of. Well, it's actually something in the science world we call a vortex. And a vortex is going to be anything that's actually going around a center point. And I want to see if we can actually recreate that with this high-tech device that we created here at the museum. Actually, this is something that you can totally do at home. We just have a couple of 2-liter bottles. We have a connector that we have here at our Explore store, but you guys can totally just get some duct tape and just tape it around. And we also have some water and some food coloring to add a little bit of pizzazz. But let's turn it over, and I want to see if we can recreate that vortex. Okay, here we go. 3, 2, 1. All right. Is it working? Is this happening? No. Okay, sorry. That was very anticlimactic. Okay, what should I do? What if we try this? What if I try to spin it this time? Let's see what happens to that water now. Okay, so I spun it. And you can actually see, oh, there's a little bit coming out. Let's see. Let's try it again. All right, yes. We have mastered the liquid vortex. With this water and creating a little spin, we're actually able to see that water rotate around that center point while there's actually like kind of a funnel of air coming down. Now, this is the quickest way to get our water to go from one place, which is this bottle, to the bottle below. And of course, there's a lot of air in that bottom bottle, but now it's, of course, just switching sides. It's actually filling up that water down below. Just a little bit left. How awesome is that? Okay. I think we can go bigger, though, because, I work here at the Museum of Discovery. We can go bigger and better. So I'm going to do just that. Okay, here we go. I like to call this one Big Bertha. Yes. Look at how much water is in this thing. We have a giant connector. We have these 2 multi-gallon little bottles right here. I'm going to try to flip it over. Now, I'm the weakest person I know, so again, don't laugh at me. When I flip this over, we're going to see what happens. And I want to see if we can create a giant liquid vortex. So let's see what happens. Ooh. Okay, I got it over. So, of course, we see those bubbles, so nothing's really happening yet. But maybe if I spin it, we can see what happens. Okay, so I spun it once. It kind of takes a couple times. Oh, there we go. Something's happening. There we go. Slowly but surely, we are creating that giant liquid vortex. If you can see closely, that water's actually spinning around and round. And of course, that air, that funnel inside, you can see it so well. Wow. Amazing. That is our giant liquid vortex, and that water's coming down so quickly because, once again, that is the quickest way to get our water to drain from one side to the other. Wow. We got rid of that water so quickly. How awesome is that? And again, this is something that you guys can try at home as well. Okay. Now, moving on to the next thing. I'm going to set this down. In talking about vortexes, I want to see if I can do that in a different way. Now, over here, I've got a trash can. Now, this trash can is unique because you can see through it, of course, but also we have it on a little plate down here, and it actually rotates, so we can spin it round and round. But we're going to put something inside of it. Now, specifically, it's going to be some fuel. Now, this fuel, I'm actually going to set it in this center plate right here. That should be good. I'm going to set it back to the side. But I'm actually going to light up that fuel with a lighter. I see where some of you think I'm going to go with this, but what we're going to do is we're going to try to create a fire vortex. Let's see if we can master this. Okay, so we've got our fire. Now, let's try to spin it once again with the fire. In 3, 2, 1. Whoa, look what we've created. We have created what looks like a fire tornado. That fire vortex. That is so cool. Now, of course, as that air is spinning around and around, keeping it in this trash can, of course, because of that wiry trash can that we have, it's spinning around that fire as well, naturally creating this vortex. Now I will say, these do happen on a regular basis, which is kind of terrifying because where there have actually been wildfires throughout the USA and the world, there have also been these fire tornadoes. So this air that kind of whips around, naturally creating a fire tornado, and some have been reported as high as 2 miles. That would be terrifying to see one coming towards you that's 2 miles. But fortunately, we could actually see it here in a really cool, fun, and safe way. But I want to still keep on the subject of vortexes, and I have another little thing to show you over here. Well, first, I've got a lovely green tarp. So with this, I want to see if we can make it move in some way. So the man who introduced us at the very beginning, Mr. Thomas, he's actually going to help me with this one. Okay, so he's getting all of our cameras set up, making sure we're going to come over to another area in just a moment. So let's see if you can hold this for me, Thomas. He's kind of getting it all over. Fantastic. He's going to hold it like a matador. There we go. Feel free to get where you need to be. Oh, lovely. Feel like I could be like a bull just going to chase you or something. Okay, so over here, I'm going to come in front of the camera so I can show you. We've got another trash can. Now, this trash can's a little bit different. You can't see through it this time, but it has like this little rubber topping right here, and you can beat it like a drum. I can create a sick beat or something. Now, I also have a solder strap, and on the bottom, we actually have a hole. It's in the shape of a circle. What I'm going to try to do, I'm going to try to take all the air that's inside this trash can, and I'm going to try to push it out of this circle right here and see what happens. I'm going to try to do it towards Mr. Thomas. So he's holding it up, and we're going to see if we can make this move with our trash can. Okay, here we go. Wow. Immediately, you felt it? Okay, fantastic. So we actually made it move. Let me try again. Okay, let me try like rapid speed even. I'm just going to go for his face now. You might be able to see that hair moving. It's not a wig. It's not a wig. That's the good news. Okay, fantastic. Well, thank you, Mr. Thomas. I appreciate it. Yes, thank you. I will take that top from you. Thank you. But as we can see, we actually made that tarp move using our little air cannon, of course, that we created here at the museum. Now, how this worked is the air was coming out of this trash can. So when we actually hit it on the end here, it pushed out that air, even though we couldn't see it, to make that tarp move, which was really cool. But we couldn't necessarily see it, right? And I want to see if we can do just that. So over here, let me see. I'm going to grab, might have to take just a second. Let's see here. It's going to take just a second for it to heat up, but we actually have a fog machine over here. And our fog machine is actually going to go inside of our trash can, and hopefully we're going to actually see it go out we're going to see what happens when we try to push all of that air out once again, and maybe we can see it. Now, this is actually something that you can do at home as well. And all you need is something as simple as a cardboard box. If you actually tape up all of the sides and actually hit it, you could actually create a little air cannon yourself. Now, you will need a parent or someone to actually help you create that circle, but hopefully, once again, you can actually create it yourself, which is fun. And of course, if you have something like a tarp or even maybe some cups, you can actually create a bunch of cups up and actually knock it down potentially as well. Okay, so since we have a little bit of extra time, I actually want to go back to a liquid nitrogen demonstration as well. So what we're going to do is do something else with our liquid nitrogen. We're going to grab these pans right here, and we're going to fill up a lot of liquid nitrogen inside here. Let's see how much we have left in particular. That's okay. We'll be good. So we have a little bit of liquid nitrogen, and immediately we can actually see that we created something on the outside. Look at here. We have created snow. Look here. Let it snow. Let it snow. That is incredible. You know, it might not have snowed yesterday, so this is what we're going to take what we can get, right? All right. So let's see how much liquid nitrogen we have for our next liquid nitrogen experiment. That's lame, right? I think we need some more liquid nitrogen. So we're going to do just that. Let's grab this. Grab some liquid nitrogen. Pour it right in. Perfect. Now, of course, like we talked about beforehand, liquid nitrogen is negative 321 degrees Fahrenheit. Now, we're going to see what happens when we mix that temperature with some hot water. Now, this temperature can be up to 500 degrees Fahrenheit in a temperature difference, and we're going to mix those together. Now, again, I want you to think about what happened with our Cheeto. Remember, my mouth was about 98.6 degrees Fahrenheit, and then, of course, that temperature of our Cheeto was very, very cold. So we're going to see what happens this time when we actually get some hot water and do this experiment. Okay, mix those together. Here we go. So we've got some nice hot water here. It is steaming. Whew, okay. Now this is pretty close to 212 degrees Fahrenheit. So the temperature of boiling water. But like I said, we're going to mix this together and see what happens. Now I want you guys in your classroom to count down with me. So we're going to start counting down from 5, 4, oh, okay, almost. I think we're almost ready. Okay, fantastic. We're good. In 5, 4, 3, 2, 1. Woo! That was crazy. Look what we created. We created a massive volcano of fog. It's coming out all over the place. Now, we mix those two massive temperature differences together. And of course, it created a lot of fog, just like our Cheeto. So all of that water vapor, but in a much more massive way, because of course we use more liquid nitrogen and more hot water, and of course created a fog volcano. And it's going to keep on coming out for just a little bit as well. As you can see, I can kind of pour it out right here. Wow, that is amazing. Now, and of course, you can see it that it's going down. The reason that it's going down is because heat tends to travel up, while cool air, or anything for that matter, is going to typically go down, travel towards the ground. But I'm going to put it back in here. And of course, we created a nice liquid mess. But I want to go back to our trash can. So let's see if we actually have our fog machine ready. Let's see if we can actually fill this thing up with fog. And we are ready. We are good to go. Okay, as you can see, got some fog happening in there. It's filling up fast. Lovely. Awesome. Okay. So I'm going to take it over here. And we're going to see what happens this time when I try to use our little air cannon, our air vortex once again. In 3, 2, 1. Oh, wow. Okay, I don't know if you could tell what's happening there. We are creating a ring right now. That is so cool. Now, it kind of looks like a smoke ring, right? Now, this is what's happening every time that I was actually using that our air cannon earlier. So even though it was invisible, those invisible air that was coming out, this is what was happening. We're actually creating these fog rings. Now, this shape that we see, it kind of looks like a donut. In the science world, we actually call it a toroid. So these toroids are anything that's like a Cheerio or donut shape, but believe it or not, it's actually rotating within itself. So if you look at a little part of it, I'm going to try to do a really slow one going towards you guys, you can actually see that it's actually rotating around a center point, just like this. And of course, we know that that is called a vortex. So we're actually creating a vortex even with our air cannon, which is crazy. Now, okay, I'm going to do some massive ones all over the place, so hopefully you can see them all over. There we go. They're going all over. Woo! We're making the studio nice and foggy over here. How cool is that? Once again, like I said, you can actually create this at home as well. And of course, if you have something like a fog machine, hopefully, of course, you can be able to master it as well and master making some toroids. But even if you don't have anything like that, you can still make it and create a really awesome air cannon. But guys, we have done so many things throughout this program. We have gone back and forth from liquid nitrogen to learning about vortexes and learning, of course, about states of matter in a really fun way. Now, of course, I know you probably have a lot of questions about anything that you saw, and I would love to answer them for you at this point. So I'm going to bring it back to the classroom, and I want to see if you have any questions about anything you saw us do right here at the Museum of Discovery.
Let's start things off with a great big round of applause for Kelsi. That was a fantastic program, Kelsi. Thank you so much for presenting that. So as Kelsi said, we would love to hear your questions. So what we may want to do is have a teacher call on a student and make sure they are nearby the microphone when they ask that question so we can hear it loud and clear. And don't forget, we'll want to make sure you unmute your mic before you ask your first question for us.
I don't think we have any questions. We thank you guys so much. Can y'all give another round of applause? Thank you guys so much.
I'm so glad you enjoyed it. Thank you so much for joining. I had so much presenting for you guys and hope to see you here in person, hopefully very soon.
We appreciate you. Thank you. Bye-bye.
Thank you all.
Guys.
Have a wonderful day.
All right. That was fun.